Okay, Sam. We'll start from chapter number 10, that is analysis of Fraser, that is transform circuits. So we will also start with the numerical portion. Okay, is it clear? You just want to cover the numerical portion. So yes, first it is yes, example number 10.1. So then 10.1. This is the circuit which is given to us. Uh, there is a resistor R1, this one, with 55 ohm. Then an inductor having 70 millihenry. Then this is the Vs, that is the source voltage transformed with respect to time. And then there's another capacitor having 35 microfarad. Then there's a voltage source V naught T. Then there is a resistor R2 and L2. This is about the figure 10.2. Now moving towards the next figure, that is by 10.3. So this is 10.3 with voltage resistance. So this is two types of having phase difference and phase shift angles with polar form. Okay. So for this equation, to find V naught in the circuit. So how to find V naught? Where is V naught? V naught is here. So V naught is a portion, this one basically, and the region of V naught is this one. Applying at the terminals of R2 and L2, between R2 and L2. So how to find the the voltage V naught for a circuit? So as we know that the value of Vs given to us is 160 degree. This is from this circuit 10.2. As I described in the previous lecture, that the first value, this is known as my amplitude, and the second, this is my phase. So phase having angle 60 degree, so it will be written as 160 amplitude with the angle of what? Angle of 60 degree. Angle of 60 degree. This is the value of what? This is the value of voltage. So because it is a voltage source, so the value of voltage is this one. Now moving towards the next part, that is Z L1. So Z L1 is J2 pi into 60. Just putting the value of pi value is 3.14. So after putting the value just like that, then it will be J into the value multiplied by 2 multiplied by the pi value, that is my 3.14 multiplied by 60 multiplied by 0.07. So after multiplication, my value will be 26.3894 ampere. Oh, I'm sorry. So for SAM, it will be ZL2 will be 2 pi into 60. Just you have to multiply 2 into 3.14 with 60 into 0.2. So this will be my ZL2 value. Now for ZC, so capacitance, so ZC is the formula is 1 upon 2, sorry, 1 upon J 2 pi 60 into the value of capacitance. This is for to find the impedance of what? Impedance of capacitor. As this 2 pi 60 is my omega value, so it will also be written as 1 over J omega C. So what is the value of C for the circuit? My C value will be this one. 36, this is given 35 microfarad. So this is the value of capacitance. So we can find the value of ZC, where ZC equals to 1 upon J multiplied by 2. Then the value of pi value then is 3.14. 3.14. Then after, sorry, I have to erase it. This is, yes. Then after 2 pi 60, so I have to multiply with 60, and with the value of C value is 35 microfarad. So
Five.
microfarad is 10 power minus 6. So it will be then 35.
So we just transform the circuit
Yes,
from polar to phasor.
yes. So it will be then GC will be, after finding the value is this one. So it will be
Yes.
minus J, and the same value 75.7 something. So this is the method to find the value of ZC for this circuit. So first, again, I will repeat it. First, we have to transform my value of what? Value of this one, Vs, voltage source. So it will be amplitude,
Yes.
this one, with angle 60
And the
degrees.
phase.
Yes. So this is my first step. Now second step for impedance ZL1. So ZL1 will be what? My 70 millihenry. So I have to find, as the formula for impedance is what? For ZL will be, it will be 2, sorry, J
J
omega L. So it will be
omega L. Yes.
J 2 pi 60 into value of what? Value of impedance, that is L. So just putting the value for ZL2, it will be same. So this is the way we have to find VC, ZL, ZL1, ZL2, and ZC. Okay, so now for this circuit, my Z naught will be, this is my Z naught. Just a minute, I have to use this one. Not on this parameter. No, this. So this is my V naught region. So my Z naught will lie here, impedance Z naught. So Z naught equals to what? It will be equals to this one, VC, okay, which will be parallel to two parameters. First parameter is this one, then I have to this one, this one, the resistor, and second is my this parameter inductor. Again, I have write that
Yes.
Z naught will be then equals to VC, which is parallel to two things. One is my resistor and other is my inductor. So it will be parallel to ZR2 plus ZL2. Then is it clear?
Yes.
Okay. Just now putting the value of VR2 and VL2, so we can find the value. So the deformed or the final value is this one. So how to calculate it? So I have to just putting some values. Just give me 1 second. So how to calculate this one? So
The V naught we can calculate it by voltage divider.
yes. So VC value, as then this is my VC value. Just give me 1 second. My VC value is this one. Yes, VC value is this one. VL value is this one, and I can solve with my simultaneously, and I can find the value. Now for Z total. So Z total will be equals to then three parameters. But first is this one, that is my Z naught. and then there are two or more parameters. Or more parameters, but this one and this one. So after finding the value of Z naught, my circuit will be like this one. I have to draw here. This is my voltage circuit. Here is the resistor. Here is the inductor, and then there is a Z naught value. So then all the values are in series. So we must add all the parameters. So first parameter is this one, the resistor. So for the resistor, it will be ZR. And what is the R? This is R1 then here. So ZR1 plus, second one is my inductor. So it will be inductor what? Inductor L1. So ZL1 plus Z naught. Okay. Then any confusion? Is it clear?
Yes, sir.
Okay. So this will be after finding ZR1, ZL1, and G0, I can find the value of ZT, which will be equals to this value. Okay. Now for the last parameter is what? It is V naught. So V naught will be equals to two things. So V naught, the ratio of V naught divided by Z naught. Again, the ratio of voltage divided by impedance equals to current. So current is same. So this value V naught, our Z naught equals to Vs divided by uh, what? This will be my Z total. Is it clear then?
Yes.
Okay. So I have to find the value of V naught. So V naught will be equals to V naught equals to this Z naught will be multiplied here. So it will be Z naught multiplied by Vs divided by Zt. So then I have to I have to put the value of Z naught, Vs, and Vt to find the value of V naught. So V naught value will be equal to this one. That it will be 160. I have to write that 126 after the calculation. This value equals to 126.0726 with an angle of 27.285. I have to write in the V naught V naught with respect to t having angle. So it will be what? First value is my amplitude. So this value will be my amplitude, and it will be written as 126.0726. After this, there is a cos of omega t. Omega is 2 pi 60. So 2 pi 60 omega into the value of t with plus the value of phase angle. Phase is 27.285. So it will be 27.285. So this is how we can find the value of V naught, or simplify with respect to amplitude and with respect to phase difference or a phase shifter angle. Moving towards the next one. Okay. Then there's a current dividing rule. So there are certain formulas you have to find how to find the current dividing rule. So just to revise it, how to find current dividing rule. So suppose that a current source with is my source current, then ampere of current is connected in parallel to, so Z1 and Z2. So this is the value as both are in parallel. This one, then this I have to, yes, it says that this value is parallel to this value, that Z1 is parallel to Z2. So it will be 1 over into 1 by Z1 plus Z2. So this is the value of Z. After this, the voltage across will be V equals to Z IS. So what is the value of Z? Z value is this one. So this will be the value of V for my this circuit. Now I1 current across this one, I equals to V upon Z1. So V is my V value is this one, then V value is this one. I have to put this value here, and then the value of Z1 just multiply with Z1. Second is my VZ2. Again, I have to put this value in V and then divide by Z0, Z2 to find I2. And then is that I I mean that I mean it will start from 1 to number of terms, that it will be 6 7 till the value equals to n. So it will be 1 upon Z1 divided by 1 upon sorry 1 upon Zi divided by 1 upon Z1 plus 1 upon Z2 and 1 upon Z3. So this is my general uh, current divider rule to find the value of current for a given circuit. So for this, I have to do a certain example to elaborate that how it works. So it will be yes. So use the current divider rule to find the currents I1, I2, I3, and I4 for this circuit. Okay. So for this, we have to start with, yes, this is my circuit with the value of R1, R2, R3, L and C, and with I1, I2, and I3 and I4 to find. So first we have to let Z1 be the equivalent, sorry, with the equivalent resistance in series with R3 and ZL. What is this one? This says that I have to suppose one thing, that my this thing is, give me 1 second, yes, this thing, then this one, where is my, this one, R3 and L, that my the connected series, that R3 and the impedance ZL impedance is basically connected in series. So this series means that they are connected, and this connected value equals to Z1. That this value is replaced by what? Z1. So Z1 will be what, as it is in, as this value is in series. So Z1 will be equals to R3. R3 is my 5 plus what the value of ZL. ZL value is J5. So it will be J5 ohms. So this is the value of Z1. So I replace my these two value R3 and L with Z1. Again, Z1 is in series with R3 and ZL1. So Z1 will be equals to R3 plus ZL. So it will be 5 plus J5. Now for the second thing is Z1. Now this one, as this is replaced by Z1, and now Z1 and this value, that is ZC, is always is also in parallel. Just give me 1 second to show it. This will be like, okay, yes, this will be like sand. I will draw this cross section only. So it will be like This is my capacitor C, and here it is an impedance value Z1. Okay, so this value
Yes.
is parallel to this one. So I am taking this
Yes.
whole system as what, as Z2. Okay, first
Z2. Yes. Okay.
I will move from left to right. This is my left.
So,
I,
sir,
yes, yes, yes,
you will do the wait. You will do the like the Z as an impedance equivalent, right?
yes, yes, yes. Impedance
Okay.
equivalent, then I have to find the value of current with respect to Z value, because it is we use current divider rule. So current divider rule, we have to compare the value of z with respect to nodes. Basically, what are the nodes? So there are four nodes then. So basically, this is first node with I1 and I2, and this is the second node with the current I3 and I4. So we have to compare this value with Z1, Z2, and with respect to Z3 and my voltage circuit VC. Is it clear, then? Then is it clear?
Yes, sir.
Okay. So then this is my system. I will replace this with Z2. So Z2 will say that this this value, that capacitance and Z1 is parallel to each other. So I will write that Z Z2 value will be, that it will be equals to V ZC parallel to Z1. Then is it clear?
Yes, sir.
Okay. So it will be, I will write here V, no, it will not say here. I have to write here. Yes. ZC equals to, sorry, Z2 equals to ZC value. Now what the value of ZC is? ZC is this one then. This is my -6. Sorry, negative J6. So it will be negative J6, which will be parallel to what? Z1. So then my Z1 value is what? It will be equivalent to 5 plus J5. So it will be 5 plus J5. So how to solve parallel? So it will be equals to minus J6, J6 multiplied by 5 plus J5, J5 divided by negative J6 with the sum. I have to sum it. So sum 5 plus J5. So after the calculation, my value will be equals to 6.923. This is my real part, minus J value with 4.6154. So this is the value of what? This is the value of Z2. So where will be my value of Z2? So just I have to erase it. Yes. So this value is my Z1. So this was in my Z1. And now the next, I do it this one. So this one, I find that this is my what? This is my Z2. Now moving towards my Z3. So how to find Z3? So Z3 will be equals to this parameter, that it will be Z R2 with the value of Z2. So it will show that Z3 value is parallel to two things, that it is parallel to R2 with one with Z2. So my Z3 value equals to R2 parallel to Z2. Okay. So what is the value of R2? So R2 value is 3 ohm, which is given to us. So 3 parallel, sorry, it is in series. So 3 plus, this is in series, not parallel. 3 plus Z2 value is what? Z2 value is 6.9231 with a negative sign, negative J 4.6154. So after the calculation, we find that the value of Z3 equals to, Z3 will be equals to 9.9231 minus J J 4.6154. So this will be equals to this one. This is the value of, sorry, this is the value of Z3. Okay, now it is the time to find the value of V1, V2, and V3 for my circuit, and also to find the value of I1, I2, I3, and I4. Let's move to find the value of I1, I2, and I3. So it will be equals to, I have to just change the color. So it will be yes. So my I1 value will be then, it will be equals to the source current, that is my IS multiply by, now this is my I1. Where is I1? I1 is here then. You have to, this is my I1. So it will be equivalent to this series, and with respect to two parameters. What are these two parameters? So first thing is, this parameter is my Z3 as I described before, that is Z3 divided by the value is R1. So it will be R1 plus Z3. Then is it clear or not?
Yes.
Okay. Now putting just the value of IS. So IS value is this one. Now what is the value of Z3? Z3, I find the value using this. So this is the value of Z3. Oh, sorry, I have to erase it. Okay, this one. So this is the value of Z3. That is 9.923 minus J 4.6154. Then the value of R1 value is 8 ohm plus the value of Z. Z3 value is, again it is equals to that the value I find. Now this is the value of I1. So my I1 value is this one, 5.9131 with the angle of 109.4966 degree ampere. Now the second thing is I have to find the value of I2. So I2 value will be, I2 value will be equals to, now for I2, what is the where it is? It is this one. Yes. From here it is also connected with my with my source current. So it will also will be is yes, is with the uh, plus, sorry, multiply with the value of my capacitance or inductance value. Now there are two things. First is my R1 here, and then for here it is Z3. So first I have taken this value, that is my R1 divided by R1, and then the parallel is plus Z3. So for this, it is also IS is given the value this one. The R1 is also given, that is 8 ohm. Then the value of 8 Z3 is also given. Now and we calculate the value of Z3. So this is how we find the value of I2 by using current dividing rule. Now moving towards I3. So I3 will be equals to, this is I3 then. So for I3, it will, the voltage source or the primary source for I3 is now I2, because I2 is the connecting source. So the value, it will be equals to I3 equals to I2 multiplied by, now there are two parameters. You have to compare both parameters. First it is this one, this one, that is my VC, and the next is my this one. This is the first parameter that we find, that it is Z1. So I have to compare with the parallel source, that is out of the source. The out of source is the Z1. So I have to multiply first Z1, then divide Z1 with ZC, multiply by, sorry, here is the sum. That first I have to write again. So it will be ZC, this value, plus V1. So VC value given, V2 I2 values also I find from using the value previous formula. I2 equals to this one. So this is the value of I2. Now what is the value of V1? V1 is also, I find that V1 equals to 5 plus J5. So from these all parameters, I can find the value of I3 for my system. Moving towards the next one, the value of I4. So for I4, again, for I4, the I4, this is the I4. The primary source for I4 is this one. This is my I2, so it will be my system will be I supplied by I2 multiply by the value. Now there are two parameters, this one and this one. So the previous mode is this one, so I have to divide with VC divided by VC plus, now this value is my Z1, as this is VC, so it will be ZC plus Z1 respectively. So this is how we find the values of I1, I2, I3, and I4 for the circuit using current divider rule. Okay, moving towards the next one, nodal analysis. Nodal analysis is very important. Okay, use nodal analysis to find the voltages V1 and V2 for the following circuit. Also find the time domain representation of the voltages, assuming that F equals to 1 Hertz. So these are the major parameters. As the figure given is 10.8. So for we have to first for the solution we have to write my given parameters. So first thing to write is I must write the values of my given as the value of R1. Just give me 1 second. R1 equals to 4 ohm. Now the value of Vs will be equals to 24 with the angle 0 degree. Uh, Now this is the value of V1. I have to here it is V1. So V1 I have to find the value of V1. V1. Then the impedance, sorry, inductance value L. So L value is J 4 ohm. Now this is C value. C value is also given. C value equals to minus J into 8 ohm. Now the value of R2 equals to 8 ohm, and with the value of V2, so V2 I have to find this value of V2. So with the frequency, assuming that frequency equals to 1 hertz. Okay, so these are my given parameters. Now moving towards the solution. Okay, so for solution, we have to summon the current for node 1 first. So where is the node 1? So this is my node number 1. So node number, I have to sum all the values with respect to the current leaving node 1. Okay, so first thing is you have to sum all the values. This is the main thing, summing current values which is leaving node 1. So this will show that my V1, where is the V1? Here it is the V1. V1 with respect to the value is minus J8. Then V1 minus V2. Again, this is the value of V1, which will be equal to minus J8. Now there are difference of what? V1 minus V2. So where is the value of V1? This is the value of V1 and V2. So the difference will come with the parameter which is involved in my circuit V1 and V1 and V2. The parameter which is involved in my subtraction of V1 and V2 is the impedance value L. So the value of L is J4 ohm. So I can write so I can write this as V1 divided by the value of C is minus J8 plus, now the difference is V1 minus V2. V1 minus V2. So it will be then V1 minus V2 divided by the value of the inductance, that is in between my node 1 and node 2. So it will be J4. Now, just I have to added both values. So it will be negative of V1 plus the value of Vs. So this value will be equals to negative of V1 plus the value of Vs divided by 4 divided by 4 divided by 4 divided by 4. So now I have to put the value of Vs. So Vs value given is 24 with the angle of 0 degree. So I have to put this value here. So this will be minus V1 with 2 plus 24 angle 0 divided by what, divided by 4. So this is the value of what, values of currents leaving the node 1. So here it is the point of node 1. Now for this circuit, multiplying by 8 yields, that I have to multiply both sides with 8. So this will leads to the solution that it will be 2v1. Just give me 1 second. After multiplying with 8, so this will be my 2v1 minus 48 plus jv1 minus j2v1 plus j2v2, which will be equals to 0. So for this, it will be just summing the value. So I have to, this is the v1. Now there is jv1 and jv1 here. Okay, so it will be what, it will be yes, so here it is j2v2. Okay, and the only parameter is my this one, so it will be 2v1 minus 48. Then this will be operated at plus jv1 minus j2v2. It will be minus jv1 plus j2v2, which will be equals to 0. Now for this, I have to factorize it. So it will be like 2v1 again. Then this is the v1 parameter first, and second parameter is this one, that is minus jv1. So it will be what, it will be minus jv1. Then the next parameter is this one, jv2, that is minus, sorry, plus j2v2, j2v2 minus 48 equals to 0. Okay, so after this, I have to compare the values of v1. So this will be like v1 will be my common, v1 with 2 minus j plus j j2v2 2v2, and which will be equals to 48. So this is the complete value of my uh, v1 with respect to v1, with respect to v2 and the constant parameter. So this value will be the completed equation for my node number one. Again, for this equation, first I compare v1 with the value that is v1 into negative of uh, j8. Then I have to I will plus the value of the difference, that is v1 minus v2 with respect to j4, which will be equals to negative of v1 plus the value of vs value is 24 angle 0 divided by 4. After simplification, this value will be equals to 2 minus j bracket close with the value of v1 plus j2v2, which will be equals to 48. Now here is the solution of basically the completion of hmm, the nodal value of 1. Now moving towards the nodal point 2. Okay, moving towards nodal point 2, this one. Yes, this point, this point. So for this point, it will be same, but I have to write the difference first. So it will be v2 minus v1 divided by the value of the difference. So difference is what, which is between. So between is this value, that it will be equal to j4 ohm. Then the value of plus with the value of v2 divided by this value, which is between, which is basically 8. So this value will be equals to 0, because there is no voltage source in the system. For there is no source involved when I am taking the value with respect to nodal 2. So this value with respect to my voltage or my source current will be equals to 0. So v2 minus v1 divided by j4, again plus v2 divided by 8 equals to 0. After simplification, this value will be equals to just give me 1 second to do. Okay, it will be like this is the primary equation. So after that, it will be 2v2 minus 2v1 plus jv2 equals to 0. Now the common term is my v2. So how to take common? That will be 2v2 plus jv2 minus 2v1 equals to 0. Now from this side, I have to take the common of what, v2. So I have to write minus 2v1 here with the value with the value equals to uh, plus 2 plus j having common v2, and this will be equals to 0. So this is the value of two nodal points, node point 1 and node point 2, with the parameters v1 and v2. Now after, just I have to compare both values. So my first value is, so my first value is 2 minus j with v1 plus j into 2v2, and this will be equals to 48. Now the next value, this is from my nodal point 1, minus 2v1 plus 2 plus j with the value v2 equals to 0. These are the two basic equations we derived from my nodal point 1 and 2. Now moving towards the solution of the system, as the first thing to do is I have to simplify my equation number 2, because there is 0. So it will be v sorry 2v1 equals to 2 plus j 2 plus j to the value of v2. Then it will be for this 2 is multiplied with v1, and when it is moved to the other side, it will be divided. So it will be, my final value will be v1 equals to 1 plus 0.5 j with the value of v2. So this is the value of v1 for my system. So after this, I have to put the values in the equation. So this will be as is the value of v1. So I have to put this value of v1 in my equation 1. Okay, so this value will be, I have to erase some parts. So just give me 1 second. Okay, so it will be 2 minus j 2 minus j with the value of v1. So v1 value is this one. So it will be 1 1 plus 0.5 j with the whole value of v2, again 2 minus j into 1 plus 0.5 j v2, and then plus j 2 v2 equals to 48. So for this system, I have to elaborate my values. So it will be equals to, after the elaboration, it will be equals to v2, which will be equals to 48 divided by the value of 2 minus j, this one, okay, 2 minus j, 2 minus j with 1 plus 0.5 j, 0.5 j, again 0.5 j plus j2 plus j2. So this value v2 will be equals to 48 divided by 2.5 plus j2. So this is the value of v2 after elaboration. So I have to convert this form because j is my complex number as it is in denominator. So I have to rationalize this value to find the value of v2. So the value of v2 will be 11.7073 with the negative of the complex value j 9.3659. 3659. So this is the value of v2 for my system. So after this, I have to convert this form into my polar form with in the angle form. So my angular form will be, I have to erase all this. Okay, so my angular form will be v2 will be equals to 114.9927 with the angle of negative 38.6598 degree with the voltage value V. So this is the value of V2 for the system. As I find the value of V1, the generic value of V1 will be it will be like V1 equals to 1 plus J 0.5 into the value of V2. So it will be V1 equals to 1 plus J 0.5 into the value of V2. So V2 value I calculated this one. So I have to put this value in this equation. It will be 14.9927 with the angle negative 38, negative 38.6598 degree. So after the calculation, you have to perform the calculation, and by using calculator, I find the value of V1. So V1 value will be equals to 16.3902 minus J into 3.5122. So I have to convert this into the polar form. So this will be my, with respect to my cos of angle. So it will be equal to A amplitude with cos 2 pi omega t plus phase angle. So it will be 16, V1 will be 16.7623 with the angle of negative 12.0948 degree voltage. So this is the value of V1 and V2 for my system by using nodal analysis. So this is the complete solution of this numerical 10.3. Now moving towards the next one. Okay. Okay. So this is the first method by using model. Now the second is by using Kramer rule. So how to find or what is the method to find the by using Kramer rule? So it will be like V1 equals to Kramer rule says that if let's say let's say we have two equations. The first is ax. Just give me 1 second. I have to raise it. So as it is ax, if it is ax plus by equals to e, and the second is my another equation. Let us say cx cx plus dy equals to f. So for my Kramer rule, there I have to find the value of x and y. So this will be value of x equals to e and then b ef and bd divided by the value of my determinant. Determinant value will find by using a b c d. So this is for my first parameter when I have given the value of x. Now for y, it will be equal to the value is a c. So I have to replace this value, so it will be e f, and this will be divided by the determinant. So determinant will be a c and b d. So this is the way to find the value of x and y for the system. As for this system, my x and y values are x value is v1 and y values v2 respectively. So it will I have to write v1, which will be equal to 48 j2 with 0 and 2 plus j with the absolute value divided by 2 minus j minus 2 j2 and 2 plus j. So after this I have to multiply with diagonal. So 48 multiplied by 2 plus j. So answer is 26 plus j 46. Sorry, 48. Then the negative sign is 0 into j2. So 0, the answer will be 0. Now for the next, it is 2 minus j plus 2 plus j. Into a negative side. And then negative equals to positive. So it will be j4. So this is the value of v1 for my system. For V2, the same way to elaborate all the values. So 48 and 0 will be elaborate here. And then I have to multiply with respect to this one. So first value will be 0 into 2 minus j. The answer is 0. And second is minus 2 into the value of 48. So this value is the minus minus plus, so it will be 96 divided by this parameter. So this is the last, this is the value of my V2. As we know that the value of what? Value of voltage equals to voltage or current equals to amplitude A into cos of 2 pi omega t with respect to angle, phase angle theta. Okay, so first it is negative 12.0948, and for second it is equals to negative 36.38.6598. So these are the values of phase shift or theta angle. So I have to put these value in my equation. So for after computing the value, so I can find the value of V1 and V2 for my system respectively. So this is the second method to find the value of V1 and V2 by using nodal analysis method. So this is the simplest method and the easiest method to carry, that you only need Cramer rule, and after the Cramer rule you have to apply the determinants. So after determinant, just you have to replace the value. After replacing, we can find the value of x and y. In this case, my x and y will be v1 and v2 respectively. Okay, now the next is my mesh analysis. Okay, so this is the example 10.4. In the circuit shown 10.10, find the mesh currents I1 and I2. Also find the voltage across L and R2 and the time domain representation of the voltage on F equals to this one. Okay, for this, okay, the first thing is uh, I have to, for mesh 1. So where is the mesh 1 and mesh 2? So uh, this is the mesh point 1, which is basically I1, and this is mesh point 2, which is I2. So it will be minus 15 plus this one. So this is the value, first value, plus J 6 I2 I1 plus the value of impedance, that is J9, with the difference I1 minus I2. So I have to write the first equation. So it will be negative 15 plus 6I1 plus J9 into the value of I1 minus I2, I1 minus I2, which will be equals to 0. This is the first equation. Now I have to elaborate it. So the elaborated form will be this one. So this is after calculating the value and just solving the value. So it will be 6 plus J9 with the value of I1 minus J9 I2 uh, equals to 15. Now moving towards the mesh 2. So where is the mesh 2? Mesh 2 is this one, this parameter mesh 2. So for mesh 2 it will be J9 with the value of what? This is J9, okay? This is the inductor value L. J9, now the difference is I2, so it will be I2 minus I1. Then there is a negative of this one, so negative 3J, then this one resistor, so plus 5I2. So this is the value of this circuit. So after elaborating the value, so this is the complete equation. So this equation is known as my first equation, and this is the second. So now I have to solve these equations simultaneously to find the values. As for the system, uh, I have to compare for I1. So I1 will be equals to I2 into 6 minus J5 divided by 9. So this is the value of I1 this with respect to I2. Now substituting the value of this one, this is now equation number 3 into equation number 1. So this value substitute in here with I1. So it will be equals to I2 into I2 equals to 1.114 plus J 0.786. So this will be equals to now finding the I1. So I1 will be equals to I2 into 6 minus J, this value using equation number 2. So just putting the value of I2. So putting the value of I2, which will be equals to 1.1147 plus J into 0.7844. So for this, we have to find the value, putting the value in I2, this value, where the now this value and then multiply with 6 minus J5, then whole divide the value with respect to 9. So from this, we can find the value of I1 and I2 respectively. Now finding the VL and VR2. So VL will be J9, I1 minus I2. So J9 will be 7.9476. This one. So this is the value of VL. So VL will be equals to J9 with the value of, where is the J9? So this I have to, yes. This is the VL. So it will be J9 with respect to I1 minus I2. So it will be J9 into I1 minus I2. Then putting the value of I1 and I2 in this equation to find the value will be 7.9476, which is the value of amplitude. And then a phase shifter angle will be equal to 4.1704 degree. And this value basically is in voltage. So VL will be this one. Similarly, VR2 is simple. It will be equals to 5 I2. So 5 and then putting the value of I1, I2. So 5 into I2. So then now finding I1t and I2t, finding the A cos 2 pi t with the angle. So so for this for this, we have to find the amplitude value and the phase shift value, and simultaneously for I2t, and then VLT and VR2t. So these are the four values: I1, I2, and then VL and V2. So this is the complete method to find the values of current for frequency equals to 1 hertz for the given system. Now moving towards the next thing, superposition principle. Okay, so this is superposition principle. Zan,
Yes, sir.
give me 2 minutes, please, for water. Okay, Zan, give me 2 minute break, please.
No problem. Take your time, sir.
Okay. Okay, Zen. Let's start. So this is basically 10.5, my superposition principle. So, so for superposition principle, I have to find the value of voltage for my circuit. Okay, so voltage is basically this point. This point is my voltage. So how to find the value of voltage at basically at point A? So
So first you have to deactivate the current source.
yes, yes, yes. So for step by step solution, I have to find the basically we have to find the voltage at point this one, which is my voltage A. Just give me 1 second. So how to find it by using formula? As we know that my voltage A V equals to IR. This is my generic formula to find the voltage. So VA will be equals to I into R. Okay. So how what is the value of I and what is the value of R? This is the main parameter to do. So for I basically then just give me 1 second. So this is my V. Mm, This is my V and the current applying to it is IB. So the primary source is IB and there is R. R is basically R3, R4, R2 and R1. So I have to take equivalent basically resistance. So my VA will be equals to V as V equals to IR. So VA I will be the value of IB with the V I R will be my R equivalent value. So this is the way to find the value of voltage. Is it clear then?
Yes.
Okay then. So for this then I have to find the value of R equivalent. So as the equivalent impedance of R3 and R4, which is given this one, R3 and R4. So both are basically, so it will be R3 multiplied by R4 divided by R4 multiplied by R uh, R3, sorry, R3 multiplied by R4 divided by R3 plus 4. So the value of R3 is 20 and R4 is 16. So after computing, I find that the R equivalent value equals to 8.8889. Now moving towards the value of my impedance ZB. So ZB equals to two things, that it will be equal to, just look at this one. ZB basically this one. Basically this is IB. So the impedance here it is ZB. So there are two parameters R2 and RC, which is in basically in series. So R2 will be 15 minus J10 ohm plus the value of my R equivalent. R equivalency will be R basically R3 into R4. So the value is basically 8.8889 I find from above. So the value is 23.8889 minus J10 ohm for this ZB value. Now I have to find the value of IB. So IB basically equals to this one. So IB will be equals to first it will be equals to the value of I1. So I1 1.4142 plus J 1.4142 multiplied by ZA. So ZA is 12.J18 divided by the ZB. ZB, we find that this one, this parameter. So after division, this value will be equals to 1. Uh, 1767 with the angle of 88.746436 degree, which will be the value of IB. So after this, I have to compute the value of IB. So What is the value of IB? IB value I will write here. IB value will be 0.0258. This is my real part plus the value of J. This is my polar part. It will be our complex part 1.1764. And the value of R equivalency is equals to 8.8 triple eight triple eight nine. So these are the two values, and after this I can find the value of VA. So VA value is this 110.4504 with the angle of 88.7436. Okay, so this is the part one number one. So now the part number two is next we deactivate the current source. Okay, so after
Yes.
yes, after the deactivate the for deactivation, this will be equals to, now I have to find the value of VB. So where is the VB? VB is my second terminal. Okay, so it will be equal to V source, then it will be equals to Z impedance value, ZD divided by ZD plus R4. So for this step, first I have to find the value of ZC. So where it is ZC value basically is n equals to this one, this parameter. Okay, sir, this one. So ZC equals to negative J10 plus the value of 15 plus 12 plus J18. So after this, the value is 27 plus J8. Now the value of ZD will be equals to, now I have to find that the parallel connection of Z3 with the, this is basically Z3 with the value, sorry, ZC, this is the value of ZC with the R3. So ZC is parallel to R3. So Z3 multiplied by R3 divided by Z3 plus R3, which will be equals to ZD. So after the calculation, this will be the value of ZD. Okay, now for this one, I have to find the value of VB. So for VB, it will be equals to V into V is my voltage source battery, which will be equals to 25 point, sorry, 25.0 plus J 43.3013. This is the value multiply with ZD. So ZD value is this one. ZD value I find from the above equation with the value of ZD plus R4. So this is the value of ZB. So as in the first part, I find the value of VA, and then of in the second part, I find the value of VB. So for total voltage according to superposition principle, total voltage is the sum of VA and VB. So just you have to sum both values. So this will be the value of my V for the entire circuit. Okay, now moving forward. Yes. Now next is my source transformation. So source transformation basically uses the source application with the voltage source to current source conversion, and the second is my current source to voltage source conversion. So this is the use source transformation to find the value of V naught across R2 in the circuit in the figure 10.20. So how to do it? Again, for this circuit, this is the circuit given. Yes. So basically, we have to find the value of V naught and RC in the circuit 10.20, which is this one. Okay, 10.20 with the value of VS 20 volt, R1 equals to 8 ohm, impedance capacitance value equals to minus J9 ohm, with the inductor value equals to J11 ohm, with the V naught parameter and with R2. So R2 will be my 6 ohm. Okay, so 6 ohm is my value of R2. Now, I have to know that I have to find the value of Z1. So Z1 basically equals to Z1 with now how to find the value of Z1. So as by using figure 10.21, this is the 10.21 which is shown above, and this will be Z1 will be the impedance which is parallel to R1 and ZC. So here is this one, R1 and ZC. So R1 basically 8, and with respect to this one, so my Z1 will be equal to minus 4.469 minus J 3.972. Now finding the value of Vs2 equals to Isz2. So Is will be the current which will be source current, which will be equals to 2.5 ampere, with the value of Z1 which will be equals to 4.49 minus J 3.972. After this, this is the value of Vs. Now in part 2, we have to find the value of V naught. So V naught will be equals to, we have to find using the voltage across R2 can be find by using voltage divider rule. So it will be equals to 11.172, this one, minus this is the real part, and then the imaginary part which will be equal to 9.9310, with multiplication and with the value 6 divided by 4.469 minus j value is j 3.972 plus j11 plus 6. So after this, after the simplification, my value is 1.7802 minus j value equals to 6.8867, and converting into polar, so polar will be 7.1131, with the angle negative 75.5061. So this is the value of V naught for my this circuit by using the theorem. So again, moving towards the next part. Next part is my Thevenin equivalent circuit. So for Thevenin, basically, I have to yes, there are basically I have to split my numerical in two part number one and part number two. For part number one, we have to find the Thevenin equation. Thevenin basically find the Thevenin equivalent voltage and Thevenin equivalent impedance. So again, in step number one or part number one, I have to find the value of Thevenin equivalent voltage and Thevenin equivalent impedance between A and B terminal. A and B terminals are basically my endpoint terminal of the circuit. If the frequency of the source is 10 hertz, if this frequency of the source is 10 hertz, what are the component values of the Thevenin impedance? So this will be my part number one. So for this one, first I have to take ZP, which is my impedance, equivalent impedance of parallel connection, which will be equals to ZC and parallel to ZR2 and ZL2. Then finding by using the values. So by putting the values, I find that this value equals to amplitude value equals to 10, and the angle value equals to negative 10.3, 10.3. 10.3889. Oh, 10.339. Now after this I have to find the value of z. Z value is 8 plus j5 uh, plus 9.8361 with a negative sign of j 1.8033. From this we have to find the value of z. Now for this we have to find uh, Thevenin voltage. So Thevenin voltage, this is the important thing. The Thevenin voltage value is V Thevenin VTH equals to Vs multiplied by Zp divided by Z. This is the Thevenin theorem across A and B terminals. Now the second important thing is my Thevenin impedance, that is ZTH. Okay, ZTH will be equals to ZR1 plus ZL1, which will basically parallel to ZP. So Z Thevenin will be equals to ZR1 multiplied by ZL1 multiplied by ZP divided by ZR1 multiplied by ZL1, and then I have to sum with the impedance value, so it will be plus ZP. So the value of ZR1 multiple sorry, this is plus ZR1 plus ZL1 multiplied by ZP, then ZR1 plus ZL1 plus ZP. So after the calculation, we can find the value of V Thevenin and Z Thevenin. So sorry. So V Thevenin value will be this one, and Z Thevenin value will be this one for my this numerical. Now this is the part number one of my solution. So for part number two, we have to find the V Thevenin. Yes, this is the same. I have to find the R Thevenin with the equivalence. So R Thevenin equals to R equivalents with the Z Thevenin. This value equals to 5.101026, and then I have to find the L Thevenin, that the impedance Thevenin, which will be equals to the value 1.034 divided by 2 pi L. Now the L is basically the value of my frequency source. So frequency source is 10, so it will be equals to 2 pi F. So 2 pi F will be that is this one. So my L Thevenin will be 10 upon 2 pi 10. The value of L Thevenin and R Thevenin respectively. Okay, moving towards the next one. Norton. Now there is a Norton. So for Norton, I have to find the Norton equivalent current IN and Norton equivalent impedance CN between terminals A and B. So this is the yes main thing to do. So first thing will be I have to find by using apply KCL. So I have to apply KCL at node 1. So by applying KCL, this is the generic form of KCL when I applied on a given system. So it will be this one. Then I have to multiply the values and then simplify it. So first thing to do is I have to apply KCL at node number 1. So for applying node number 1, so this will be equal to 12.12 minus V1 divided by 5, which will be equals to which will be equal to which will be equals to V1 divided by I9 plus V1 divided by minus J4 plus V1 divided by 6. So this is the when I apply the KCL at node number 1. So from this, after simplification, I can find the value of V1. Now in the part 2, we have to find the Norton equivalent impedance. Okay, so impedance will be equals to R2. Where is the R2? So this is the point R2. Now which is basically parallel to C, VC, VL, and this one, that is the R1. So it will be written as Z Norton. Z Norton will be R2 plus R1 parallel to L, parallel, which is my ZL, basically ZL, and which will be parallel to ZC. So after this, it will be equals to R2 plus 1 divided by 1 upon R1 plus 1 upon ZL plus 1 upon ZC. So this is the generic form to find the value of Z Norton for my impedance, which is the basically Norton equivalent impedance for a given system. So just you have to put the value of R1, ZL, ZC, and R2 to find the value of Zn. Okay, moving towards the next one. So now there is basically the summary. So summary basically for the chapter number 10. So voltage divider rule, current divider rule. We have done all these parameters. First, I will done the voltage divider rule, then current divider rule, then nodal analysis, mesh analysis, superposition principle, then after source transformation, Thevenin's theorem, Norton theorem, and apply to phasors transform circuits. So these are all the parts basically we done today. And the next thing is transform a circuit to frequency domain by transforming capacitors by impedances. So for capacitor, inductor, and resistors, so when applying to capacitor, it will be 1 upon j omega c. The value of omega is 2 pi 60. Again, for the inductor, it will be equal to j omega l. So omega value equals to what? It will be equals to 2 pi 60. So the behavior of any circuit with respect to a pair of terminals can be represented with the Thevenin theorem. So we can represent with respect to Thevenin theorem the terminals or ports given to us. So first thing is there must be some circuit, some load, some resistor, and there must be some two terminals, two nodal points are there to find the values. So first will be my reference value or the source value, and the next will be my V naught or I naught, which is basically I have to find for my given circuit. So this can be found by using Norton theorem. Now the next one is uh, now determine the Thevenin or basically Norton components. So there must be an unknown circuit. Unknown circuit will with the V naught. So V naught is the voltage across positive and negative terminal. Then there is a equivalent circuit which is known as open circuit voltage, which is basically direct measure of V Thevenin. So V naught basically equals to V Thevenin. So I have to compare with my values. So when I separate it, there must be a resistor, there must be a voltage source. So the voltage source must be equal to V Thevenin. So V naught will be equals to two parameters. This one, R Thevenin, R Thevenin, and the value of V Thevenin. So V naught at any point will be equal to which will be equal to two things. First thing is my VThevenin, and second is my RThevenin. This is when open circuit voltage is a direct measure of VThevenin. When there is short to the output voltage. So what is the meaning of short? This means that this positive terminal is connected to negative terminal and there's a flow of current. So what will happen? So there must be a current which will be equal to VI source. Okay, so it will be I equals to V upon R. It will be V Thevenin divided by R Thevenin. So my R Thevenin value will be equals to V Thevenin divided by I. V Thevenin divided by I. So so this will be equals to V equals to IR, and for this when there is a current, so it will be equals to V Thevenin divided by R Thevenin. So just summarizing two major points, that when there is voltage source, only voltage source, which is V naught C. So this will be equals to uh, V Thevenin, and in case of when there is unknown voltage, so unknown voltage will be equals to my I Thevenin, or when there's a short. Basically, short means there must be an current flowing from terminal positive to negative. So this will be equals to the ratio of V upon R. So in this case, it will be the ratio of V Thevenin divided by R Thevenin. So this is the main points regarding the Thevenin or Norton components. So you have to take notice all about these. So this is all about today's lecture. And any question from today's lecture? Then, hello.
Yes, sir.
Any question from today's lecture? Is it clear?
Everything is clear, doctor.
Okay, okay. So I think it is basically the main component, or general things that are basically included in every semester in university level. So take up practice, and also do some examples regarding these, especially especially for Norton, and then Norton or Thevenin theorems, and superposition theorem. So inshallah we'll meet tomorrow for next lecture. So hopefully
Okay.
you understand each and every point. So then
Yes.
goodbye from today's lecture.
Thank you, sir, so much.
Okay, okay. Ji.